All right, so I'm gonna do a demonstration. Sometimes it'll be an actual demonstration. Sometimes it's just some weird online simulation I found in the morning. The point here is I don't want to talk at you guys. I want you guys to make a guess on all of these things by yourself while I do the demonstration. All right, so first things first. Let's, oh, everyone has access to this now, right? Yeah, like the notes. Yes. All right. So, things first.
Have you ever gone on mechanical bull?
No, I have not. I don't want to though.
It's amazing.
Okay. So first things first. In the first box over here, if you would draw or on your paper or somewhere, just ignore the man, ignore everything else. Just draw a coordinate system. So the ruler and the direction you're calling positive. So origin and something that, and the positive direction. All right, everyone have their coordinate system? So it should look something, oops, should look something like, something like that, right?
Can't see that.
Oh, shoot.
Oh darn. You should just hold your iPad up and hope everybody sees.
I'll do this. So 0, -10, and 10, with some indication of what direction you're calling positive. All right, simple enough. Good. All right, now I'm gonna do a bunch of scenarios here. So what I want you to do is draw a table where one column is the scenario, and there are 4 of them, and the other column is a delta x over here. So calculating the displacement. For each of these scenarios, you're going to calculate the displacement of the man. All right? All right, we good? Cool. Okay, so the first situation, we're going to start at 3. Starting at 3, and we're moving back to the origin at 0. So initial, final. Initial, final. What looks clearer? Number 1 or number 2? That was a joke. Laugh when I'm failing you. All right, in this case, what was my displacement? -3, right? Remember, direction matters. Because our initial position is 3 over here, right? But our final position is 0. So to calculate that, that's final, 0 meters, minus the initial. And that gets you -3 meters. Everyone okay with that? All right, second scenario. We're starting at 5, and we're going to 8. Starting at 5, going to 8. What's the displacement?
-3 meters.
3 meters, right? Positive 3 meters. Remember, we're starting at 5, that's our initial, right?
Yeah.
Our final is 8. Final minus initial, 8 minus 3. Negative, right?
I said negative. you
Oh,
said
I'm sorry.
negative.
I'm not good with numbers.
Wait, but if the finals is 8 meters and the initial is 5, isn't it positive?
No, it's starting at 8 and we're moving to 5.
Oh.
Yeah. All right. Okay for everyone? Good? Yes. All right. Scenario 3, we're starting at -6. We're starting at -3 and we're moving to -6. So -3 to -6. -3 to -6. I know, exciting, right? What's the displacement? -3, right? So -6 meters minus -3. Two minuses, what happens to them? Turns into positive, right? -3 meters. Good. All right, last one's a bit more complicated. We're gonna move to -8. We'll start at -8, then to -2.
If you could double negative.
Oh. And -2, then to 3. What's the displacement?
11.
So -8 to -2 to 3. Here's a better question. Did you need to know that the guy went to -2 before going to his final position? No, right? And that's the point of displacement. It doesn't care what happens in between. It only cares about two things. It cares about the initial position and how many units in the straight line you need to walk to get to your final position. Final minus initial. And this is going to be a recurring theme throughout this class. If the equation doesn't have a term for it, it doesn't mean that their thing isn't happening, right? Just because the equation doesn't have time in it, doesn't mean that time's not moving forward. It's just that we don't care about it. No matter what the time is, it's not going to affect it. Similarly, for displacement, since it's final position minus initial position, we don't care about any of the positions in between. We only care about the final and the initial. That's all you need to calculate it. So delta x.
So it's 19.
But it said it starts at the origin.
Oh,
So wait, we don't need to know total.
You don't need to know.
So total distance is like, oh, we don't need to know total.
okay.
Oh, so
Even
it's
easier.
fine.
Starts at the origin. Goes to -8. Goes to -2. And then goes to 3.
Oh, so 5 meters. Sorry, Keen.
So if it starts at the origin, what's my initial position? 0. And what's my final position? 3. So 3 minus 0, what's that? 3.
Wait.
You said -8 was the initial at first.
No, then it solved it. It just starts at the origin, yeah.
Okay.
Sorry, I confused these things
So
sometimes.
it's right, 3?
You were right.
Oh my
That was
goodness.
still-
Don't judge me, alright?
He's throwing my aura on. Oh, that's right.
Okay, but anyways, the point still stands. You need a final position, initial position, anything else, you don't really care about when calculating displacement. Does this make sense for everyone?
Yes.
Yes? Okay. Alright. So that's most of the lecture I wanted to get done today. The rest is really for you. Alright, I'm gonna spend 2 hours working on your homework while I step. No, just kidding. I'm gonna teach you guys stuff.
Oh man.
Why would you want that? It's a waste of time. No, we're gonna do fun, interactive activities. And then we'll yell at you for not interacting enough.
My finger hurts.
Alright, I'll fill this out. Alrighty. So, last piece of definition I want to give you before we actually do some real problems in here is to define what a motion diagram is. And a motion diagram is basically drawing the picture of a moving object. So, one of the tools used to help visualize motion, that means how do we draw a picture, is something called a motion diagram. And it's a really simple idea. So your moving object is going to be represented as a dot. Now, why do we choose a dot? Yes, because it's the easiest thing to do, right? You don't need to draw elaborate pictures for everything, all right? If something says, oh, a car, don't draw an actual car. Just draw a dot. And the reason why this works is, imagine you're hitchhiking or something. And you see a truck ignore you. It passed by you at like 60 miles an hour. If you somehow painted like a red dot on that truck, and then you went blind to the point where you can only see that red dot, so red dot zooms past you, and I told you that red dot represents the truck moving in a straight line. Would you believe me? Yes, right? And here's why. Here's a truck. It's moving in this direction. I took some red paint. I just painted a dot on here. And then I ignored everything else. And I only wrote the dots down. I told you, this represents a truck moving in a straight line. Believable, right? Now, the reason why this works goes back to modeling. We're stripping all the unimportant details, such as the truck and its wheels and all that stuff, into a simple dot picture like this. Because this is all the information you need to do physics with the truck, at least at the beginning. All right? That part makes sense?
Yeah.
Good. All right, there is at minimum in your motion diagram a coordinate system and time labels. That means what order are your frames happening in. Because if I just draw like 3 dots like this and they say there's a truck moving, but what information are we missing for these 3 dots over here? Yeah, which happened first, which happened second, which happened third, right? If it happens 0, 1, 2 like that, then which direction is the truck moving in?
Right.
To the right, right? Everyone see that? If I say this is 0, this is 1, this is 2, which direction is the truck moving in? To the left, right? So, when you're drawing these, always make sure label your points so that you actually see the motion. This is like every physics class says how do you solve physical problems. Number 1 thing to do, draw a picture. This is drawing that picture. All right. And there is a displacement vector between each object position. So between each individual dot, there's a displacement. We draw that in. This will become important sooner rather than later. And physically, we can think of a motion diagram as a real life representation. So this is us drawing what's actually happening. There are other ways to represent motion, but this is the easiest one. And I always tell people on tests, you should never leave like a question blank. Because even if you know nothing about the physics, the very least you can do to get like 1 out of 10 points, draw a picture, all right? Tells you you at least read the problem and try to think through it. All right, so we don't have one formula here, but this is a general problem-solving strategy. I want you guys to practice on your homework, how to set up problems. Oh, sorry. Any questions on this setup over here? We good? Still awake? Barely? Hey, 2 more hours. Okay, you might be thinking, oh my God, I'm stuck with this idiot for 2 more hours. But I'm thinking I'm stuck with these 27 idiots for 2 more hours. So, you know, Newton's third law, right? For every action, there's opposite and equal action. Oh, by the way, I don't want to tell you this. I have a lot of intrusive thoughts. Sometimes these can come across as mean or insulting.
It's just as humor, guys. Come on.
All right. So never think that when you ask a question, never think that I'm annoyed by a question. Because I'm annoyed by the general idea of you, all right? So you might as well just ask your question. All right. So, but seriously, if I ever say anything too stupid, just call me an asshole. It's fine. All right. I can learn.
Try not to.
Yeah, give me a week. All right, so let's take a look at the example here. You have an object that starts at 15 meters. So coordinate system, direction I'm calling positive, and my person, which is that 15 over here, right? And I move to 9 meters over here. So this is 0 and this is 1. So what this is telling me is that I'm starting at 15 meters and I'm moving to 9. All right, simple enough? Okay, after I draw my picture, here's part 2. I need to pick an equation that's actually useful to me. But before doing that, I need to ask myself, what am I solving for? So, look at part A over here. What am I solving for?
Distance travels.
Distance travel, right? And for part B, what am I solving for? Displacement, right? What delta x is. All right, so for A over here, if I just want the distance, what do I need to do?
Subtract 15 minus.
Yeah, or just count the amount of steps you've taken, right? So 15, 14, 13, 12, 11, 10, 9, that's 6.
Meters.
That's 6, right?
Yes.
Now, distance. Should this have a positive or negative sign?
Negative.
Distance.
Oh, positive.
Distance.
Positive.
Wait,
What is
displacement or distance?
distance?
Oh.
So is distance a vector? No, right? Distance is just a number, right?
Oh.
And if it's just a number, no direction, right? So for one dimension, how many directions can you move in? 2, right? One called positive, one called negative. But if you don't care about the direction, you can't have a positive or negative sign, right? Does that concept make sense? So when you write this number, it's just going to be 6.
Oh.
All right? Careful. Make sense?
Yes.
Following? All right, displacement. What's the displacement? You guys should be good at this by now. What's the equation I use?
Displacement.
Just a definition, right? We only have one.
Oh, the initial from
So what's my final position?
-6.
15, right? Final, oh, wait, sorry, 9. 9 meters.
It is?
Yes, because you end up at 9. And what's my initial position? 15, right? So what's my displacement? -6, right? Here, displacement is the vectors, and it's negative. Is that okay?
Yes.
Right, because it tells me I move 6 meters, and I move 6 meters in the negative direction, right?
Yes.
All right, so you may not believe it, but every problem in physics is going to be set up the same way. Draw a picture, find the equations you need, do the math, and check that your answers make sense. Follow those 4 steps, and I guarantee you that these 6 weeks are going to pass by less slow than you might expect. Again, it's not easy, but and the nice part about this is if you set a problem like this, I tend to give more partial credit because it's easier to see what you're thinking. If you just write, oh, here's a problem, maybe delta x, blah, 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 just say, yeah, I'm not grading that, dude. All right? So, all right, now is your turn. This is the audience participation.